Hi, good morning, everyone. Thank you so much for having me today. So I'm going to talk about a diagnostic study of the Martian sky over the Bay Area on September 9, 2020. So this is a project in collaboration with Dr. Sally Newman and Professor King-Fai Lee. So you might wonder why Martian sky and Bay Area is like a thing in a title. So
Hi, Lynn. I'm sorry, I
yeah,
didn't mean to interrupt you. I apologize. You're
yeah.
not in slideshow mode, so I just wanted
Oh,
to help you out because I
um,
can see all of your slides here.
okay. Let me try it again. Um, is this in the, what about this one?
Yes, that's perfect.
Oh, okay, sure. Thank you.
Thank you.
Okay. Um, so before we start, so I would like to let us like just time travel back to September 2020. And then it's like in the middle of the pandemic, and then you were trapped in your house and you're probably, like working remotely. And then you wake up in September 9 and boom, you are just trying to have a cup of morning coffee and you're waking up to this scenario. And you'll be wondering, am I like waking up at a wrong planet and am I in Mars or something? So the first thing you probably do is, take a picture and post it on like Instagram or like Twitter, right? So, but anyways, we did not wake up on Mars. So this is still San Francisco in September 9, 2020. So what happened that day? So basically what happened is in San Francisco, California on September 9, 2020, a Martian sky phenomena was seen over San Francisco area, and it was believed to be caused by a thick layer of haze that may originated by numerous wildfires across Northern California and Sierra Nevada. But before I go further, I would like to explain why this wildfire is so special and important in the Western United States. So that fires could be caused by natural events or it could be an anthropogenic event. Human can set up fires maybe like accidentally, like a spread of like campfire, or maybe on purpose for commercial, agricultural, and development purposes. So we burn down the vegetation so human can build more houses. And then, but we could also like put on prescribed fires. So it is basically the fire that we put up scientifically that we could control it, but we meant to put it out. But the thing that's special about a wildfire in Western USA is that we are discussing today is it is caused by extreme drought or heat. As we know that California right now is still in the middle of mega drought. So this is what make it unique because it is a sign of climate fluctuation. In the other word, it gives us like hint or clues about global warming and even like natural fluctuation like ENSO event. So so basically there's like a lot of wildfire event going on, but why is this event on September 9 that was so interesting, that is so appealing to us? Because like what we came across in the news is that we realized that people were saying that, oh, I didn't smell any smoke. I pulled back my curtains and it was so dark, it's orange, it felt like an apocalypse, but I've never seen anything like this before, but I did not smell anything. So um despite the whole dark orange sky. So you think that the air is not looking good, what will we do? The first thing we will do is we will go on and like check the weather forecast and like the air quality index. But to our surprise, the air quality on that day during the orange sky, it is not rated as hazardous on that day. So all of this was against our initial intuition, indicating that, oh, the color of the sky is not equal to the air quality. So what actually happened on that day? So the hypothesis is that the haze layer stayed above the boundary layer on September 9. So we could still see the orange sky, but at the same time, we did not smell anything because the air or like the pollutant was trapped on top of the boundary layer. We could only see it. And it's only subsided only on September 10, which is the next day of the orange sky. So in order to verify our hypothesis, first we look at the ground-based data. We retrieve the data from California Air Resource Board, and we measure the surface atmosphere, and we analyze the key pollutant like PM2.5. Next, we also run a quick high-split black trajectory model to see roughly where does the pollutant that caused the orange sky comes from. Is it a wildfire? Which is the wildfire that caused the whole orange sky event? So this is the result that we got. So this is the data we downloaded from the Air District Ground Station reported to CARBS. And in the left panel, we see that the PM2.5 level on the day of the Martian sky was around 30 microgram per meter cube, which is under 35 microgram per meter cube as defined by the 24 hours national ambient air quality standard, which is, it is safe for us to like breathe in. But we can see that it is like the concentration of PM2.5 shoot up next day, which is on the right panel. It shoot up over 100 microgram per meter cube, which is at the hazardous status, as shown at the right panel. And the location of the station are indicated by the pink triangle in the slide. So for this slide, I would like us to begin with like the dark blue line at the very bottom of it. So this is the PM2.5 data on the Martian sky, which is on 9 September 2020. So on that day in the morning, the PM2.5 was around 20-25, and it shoot up, but it is still, it is increasing throughout the day, but this is still not quantified or like classified as dangerous or like hazardous. But as we can see, starting at the next day, which is the bright blue line over here, it started to shoot up, and then we can see a immediate increase on around the afternoon. So by the following of a few days, which is indicated by the green line over here and the light green line over here, it stayed above like 50 microgram per meter cube, and it only come down or like decrease on the 4th day, which is indicated by the red line. So we can see that the PM2.5 was at a concerning level in the following day. So we know that the whole PM2.5 that breathed in by the resident in the Bay Area during the whole after the whole Martian sky event is classified as hazardous. So next, we wanted to know like where does the pollutant come from. So we look at the high-split black trajectory model, and we see that we see data from 3 elevation. The first one is from 300 meters, and then the green one was from 600 meters, and the blue one was from like 1 kilometer, which is 1,000 meters. And then we run the trajectory for 12 hours. And I would like to highlight the dark blue trajectory, which is above the boundary layer. We can see that it actually came across or like passed through the North Complex fire that's labeled as A in the map. So it is a possible contributor to the orange sky on that day. And the challenges we face when we are trying to like investigate what happened on the day is, first of all, we wanted to look at the vertical transport of it, because we want to know why does the air or like the plumes stay over on top of the planetary boundary layer. So we checked the satellite data. So we realized that there's very limited vertical data because we check Calypso and it provides vertical information. But as we know that we checked the swath path, and then we realized that the satellite doesn't flew over San Francisco on the day, so we don't have sufficient information about that. And then also we realized that on that day, or like at that period that we are trying to investigate, there are many fires from Oregon and Washington at the same time as those in California. So we do not know what's like the exact fire that's emitting the aerosol. So the conclusion is that the result is consistent with the hypothesis that the haze layer actually stay above the boundary layer. So it means that even though we see the orange sky, but the air quality was still considered safe. But the air quality on the next day, which is the 10th of September, even though the sky was not orange, we started to see the increase of PM2.5, which means the air quality is not safe to breathe in. So the future work that we are planning to do is we wanted to look into other pollutants like NOx and ozone, CO and CO2. And then we also want to look at other satellite data that may give us some hints about the vertical distribution or like the dynamics of the plumes. And then we also wanted to look at the radiative transfer model to answer the question of why the sky is so orange, what makes the sky orange. Yeah, that's all from me. I'm happy to open question. Thank you.
Thank you. I had a question. So anybody else has questions, please put it in the chat. My question was this kind of sky, how far around the Bay Area was this sky evident? Because I was wondering, is that information available in places like further to the south? How far south, how far north, that sort of thing? Because you were saying that there's so many potential sources of that material from different fires.
Yeah, so we also like wondered the same question because we got the information from the news because everyone was talking about, oh, there's an orange sky in San Francisco. And then we also thought about what about San Jose and like the other places. And then, but we couldn't have like sufficient information yet about like the phenomena of the orange sky, like to which extent do we see the orange sky? Yeah.